In this video, we will discuss period and phase shift. As always, I caution you that you must learn to use your own calculator. On the bright side, I have a very easy to use web resource to offer you. www.desmos.com/calculator is a simple graphing calculator for which you only need to type the function as you want it to get the graph. By typing tan pi x over 2, Desmos automatically translate this to tangent of pi times x divided by 2. Desmos is an excellent and free resource for graphing and bypasses the need for a physical graphing calculator. Another option is to go to www.wolframalpha.com. Wolfram Alpha is called a computational intelligence by its developers and can do all sorts of things, but by entering plot tan pi x/2, you will receive a graph you need, though it will not get the options to zoom in and out and slide the graph around that you get from Desmos. However, entering just tan pi x over 2 will give you not just the graph, but a lot of useful information about the function. We refer to the repetition of a graph of the graph of sine or cosine as waves. The wavelength is the distance along the x-axis of one repetition of a wave. Wavelength is represented by the Greek letter lambda. If the x-axis is a time variable, the time it takes for one complete wave to pass through a given point is the period, t. The number of waves that pass through a given point in 1 second is called the frequency of a wavelength, f. Frequency and period are reciprocals. That is, f equals 1 over t or t equals 1 over f. Frequency is measured in hertz, or Hz. That is, 1 hertz equals 1 wave or cycle per second. Common measuring units for frequency are the kilohertz. 1 kilohertz is 10 cubed, 1,000 hertz. Megahertz, 1 megahertz is 10 to the 6th, or 1 million hertz. And gigahertz, 1 gigahertz is 10 to the 9th, or 1 billion hertz. Find the frequency of a wave that passes through a given point once each 0.00008 seconds. F equals 1 over t, which is equal to 1 over 0.00008, which is 12,500 hertz or 12.5 kilohertz. 12,500 waves pass through the point each second. Wave velocity v is the rate at which a position on the wave changes or moves. Wave velocity is related to frequency or period and wavelength by the formulas v equals lambda f and v equals lambda over t, where v is the wave velocity, lambda is the wavelength, f is the frequency, and t is the period. A national public radio, NPR station, has an FM band frequency of 91.1 megahertz. The speed of a radio wave is the same as the speed of light, which is 300,000 kilometers per second, or 300 million meters per second. Find the station's wavelength in meters. Here we've got v equals k times f, which is lambda equals, that should be v equals lambda times f. I don't know where the k came from. Sorry about that. So lambda equals v over f. Well, that's 300 million divided by 91.1. So that's 300 million meters per second over 91,100,000 waves per second, or 3.293084523 meters per wave. The length of each wave is about 3.29 meters. One of the most common applications of waves is in alternating current. For example, in a generator, the current I changes according to the equation I equals capital I times the sine of x, where capital I is the maximum current and x is the angle through which the coil rotates in a magnetic field to generate an electric current. The voltage V changes according to the equation V equals capital V times the sine of x, where the maximum voltage is V, capital V, and the angle through which the coil rotates is x. Both of these equations are examples of an equation in the form y equals a sine x for a greater than 0. In this equation, a represents the amplitude or maximum value that the graph will reach on the y-axis. The minimum value is represented by negative a. The book explains how to find the amplitude of a graph using a calculator, but again, this is some specific type of calculator. I'm assuming it's a TI-83 or TI-84, but the book does not state which. As always, learn your own graphing calculator. However, a major part of figuring out the amplitude of a wave function, such as sine or cosine, is to figure out the value of x for which the function is at its maximum. For cosine, this will happen when the argument of the cosine is equal to 0. For sine, it will happen when the argument is equal to 90 degrees or pi over 2 radians. Set the argument equal to the appropriate value and solve for the variable, generally x or t, and you'll find the value of the variable that gives you the maximum value of the function. Plug that value back into the original function to find the amplitude of the function. As a caveat, this may not give the amplitude if there is a vertical shift to the function, but we won't worry about that here. The maximum voltage V in a simple generator is 30 V, 30 volts. As the coil rotates, the voltage changes according to the equation V equals 30 sine x. Graph the voltage changes for one complete revolution. Set the minimum Y value to be less than the amplitude and the maximum Y value to be greater than the amplitude to show the graph in the calculator window. Determine the voltage at 210 degrees. The graph of the voltage changes is shown here. The voltage at 210 degrees is V equals 30 times the sine of 210 degrees, which is 30 times negative 1/2, which is equal to negative 15. In the equations y equals sine x and y equals cosine x, the coefficient of the variable x is 1, which indicates that the period of the function is 360 degrees or 2 pi radians. A change in the coefficient will result in a change of the function. In the equation y equals a sine bx and y equals a cosine bx, the period p is founded by the formula p equals 360 degrees divided by b. To find the period of a function in the form y equals a sine bx or y equals a cosine bx, first identify b, the coefficient of x, and second, divide 360 degrees or 2 pi radians by the coefficient of x. P equals 360 degrees over b for degrees, or p equals 2 pi over b for radians. Find the amplitude and period in degrees of the function y equals 3 cosine 2x. Graph the equation to show two periods. The amplitude of the function is 3, the value of a in a cosine bx. The period is p equals 360 over b, which is 360 degrees over 2 or 180 degrees. The graph is shown below. All graphs in the form a sine bx pass through the origin, and all graphs in the form a cosine bx pass through the point 0a. If the respective changes do not pass through the appropriate point, the function is out of phase. The phase shift is the distance between two corresponding points on the appropriate reference graph of y equals a sine bx or y equals a cosine bx and the out of phase function. The equations for out of phase functions are y equals a sine bx plus c or y equals a cosine bx plus c, where c is not equal to 0. To find the phase shift of an out of phase sine or cosine function, first find the value c divided by b. Second, if c divided by b is positive, shift the graph c divided by b units to the left. If c divided by b is negative, shift the graph c divided by b units to the right. For example, graph y equals 5 sine 2x and y equals 5 sine 2x plus 90 degrees in the same rectangular coordinate system. The amplitude and period of both functions will be the same. The amplitude is a equals 5, and the period is p equals 360 degrees divided by b, which is 360 degrees divided by 2, or 180 degrees. The first function passes through the origin. The phase shift of the second function is C over B equals 90 degrees divided by 2, which is 45 degrees. 45 degrees is positive, so the graph is moved to the left. The graph is below